Every year, humans produce more than 2 billion tons of waste, and glass makes up nearly 20% of it. Now picture a single bottle thrown away, buried in a landfill, and lasting millions of years without ever breaking down. That's a frightening thought. But here's the amazing part. Glass can be recycled endlessly without losing its quality. And that's where our journey begins. A fascinating process of manufacturing and production that transforms shattered fragments into brand new, shining bottles. Get ready to discover how the everyday things we use are made, as we uncover the secrets of massive factories and the complex industrial systems that power them. Every glass bottle you see on the shelves has already gone through its own industrial revolution. Entire cities rely on efficient systems to collect, sort, and transport this material, connecting consumers, logistics, and factories in an almost flawless chain. From bottle return machines in Europe to specialized trucks in the United States, every step is crucial to ensure that the raw material arrives clean and ready to be reborn. This is the real world of industrial filmmaking, where we see exactly how each piece is crafted with precision and care. Imagine thousands of bottles flowing like colorful rivers inside the factory, a mesmerizing and hypnotic spectacle of movement and transformation. But before we dive into the full production process, think about the impact of this system. Recycling doesn't just reduce waste, it saves energy and resources, turning discarded glass into a valuable asset. Every recycled bottle reduces the need for raw materials, lowers CO2 emissions, and keeps the cycle of manufacturing in motion. In this video, we'll take you step by step through the journey of recycled glass, from the moment broken fragments arrive at the plant to the instant they emerge as brand new bottles. Get ready to enter a world where technology, industrial engineering, and human creativity come together in remarkable ways. The glass that arrives at the factory isn't just trash, it's a valuable resource waiting for a second life. In Europe, bottle return systems encourage people to deposit their glass into machines that scan, sort, and give back a small refund. By the time these bottles reach the plant, they're already pre-sorted, cleaned, and ready for production. In the US, fleets of specialized trucks travel through entire cities, collecting tons of bottles and delivering them to massive recycling facilities, showing just how vital logistics are to keeping the manufacturing cycle alive. It's impressive to see how all of this works with such precision and organization, bringing industrial engineering to life. Inside the factory, the process is all about accuracy. Every piece of glass is carefully sorted, cleaned, and separated by color, removing any contaminants that could compromise the final product. High-tech machines work alongside human inspectors to ensure only the best material moves forward. Green, brown, and clear glass are divided with optical sensors that scan thousands of fragments in milliseconds. This extreme level of control transforms a chaotic pile of shards into a uniform stream, ready to be crushed, melted, and shaped, demonstrating how every bottle is made with factory-grade precision. And the impact goes far beyond the factory floor. Each recycled bottle saves energy, cuts carbon emissions, and contributes to a sustainable cycle of glass production. When we understand how these things are made, we realize that modern manufacturing isn't just about machines or technology, it's about optimizing resources, protecting the environment, and creating products that serve society more efficiently. Watching these massive factories work in perfect synchronization gives us a glimpse of the true power of industrial engineering and the human care behind every glass bottle that makes it to the shelves. When the trucks finally arrive at the plant, they're carrying mountains of bottles. Each one weighs just a few ounces, but together they add up to tens of tons. Huge plastic containers are packed with colorful glass, waiting to be transformed, as forklifts carefully unload every batch. The sight is breathtaking. A sea of green, brown, and clear bottles forming almost artistic patterns, while the metallic sound of glass clashing together creates a unique industrial symphony. And it's here, in this moment, that the true magic of large-scale manufacturing begins. Transportation logistics isn't just about weight, it's about precision and timing. Every truck follows a carefully planned route to save time and reduce costs, ensuring the steady flow of glass arrives without delays. Once at the plant, the mountain of bottles is transferred to the receiving area, where massive steel ramps guide the fragments onto the first conveyor belts. At this stage, the material still looks chaotic, but every piece already has a destination, revealing the planning and industrial engineering behind each step of the production process. As operators move crates and check the loads, the glass is prepared to enter the production line. Automated machines and human workers collaborate, aligning pallets, removing obvious contaminants, and getting the material ready for the more detailed sorting to come. This stage is critical. Any mistake in transport or receiving can compromise the quality of the recycled glass. It's fascinating to watch how things are made in this early phase, where organization, rhythm, and precision determine the success of the entire manufacturing cycle, whether for bottles, jars, or other glass products. From there, the glass moves on to the first sorting belts, where machines and human operators work in perfect sync. Vibrating screens sift out dust, sand, and tiny shards, while sharp-eyed workers manually remove paper, plastics, or anything that doesn't belong. Every movement is intentional, ensuring that only clean, usable glass moves forward to the next stage of production. Watching this balance of technology and human touch is mesmerizing, proof that precision and care go hand in hand in modern manufacturing. Next, the glass passes through magnetic separators that pull out caps and stray pieces of metal, leaving only pure material behind. This step is crucial, because even the smallest contaminant could compromise the quality of the final product. As the magnetic field captures metal, the glass continues down the line in a smooth, uninterrupted flow. Seeing the chaos of discarded bottles transformed into neat, ordered streams of recycled glass is almost hypnotic, a clear demonstration of industrial engineering at work. As the combined mechanical and manual sorting progresses, the material gets closer to the grinding and melting stage. By now, every fragment is clean and separated, ready to become part of new bottles or other glass products. And this stage isn't just technical, it's visually stunning. Piles of colorful glass glide across conveyor belts, sensors flash with precision, and operators watch every fragment like conductors of an industrial symphony. This is the moment when the magic of large-scale manufacturing becomes clear, showing how glass is made with organization, efficiency, and breathtaking visuals. After the initial sorting, the glass moves on to the color separation stage, where precision is truly impressive. Optical sensors analyze every fragment in milliseconds, identifying shades of green, brown, and clear. Even a tiny piece out of place could affect the quality of the final product, so airjets automatically direct each fragment to its correct spot. It's visually mesmerizing to watch the glass flow as if it has a life of its own, each color following its own path, showing how glass is made with perfect organization and precision. While the machines handle the main separation, operators remain vigilant, manually removing stubborn contaminants like ceramic shards or undetected metal pieces. This combination of high-tech automation and human inspection ensures the material is uniform and reliable for the next grinding and melting stage. The speed and synchronization are astounding. Tens of thousands of pieces pass through every minute, creating a nearly hypnotic rhythm that keeps viewers captivated by the industrial process. This stage isn't just about looks. Purified, color-sorted glass saves energy during melting and ensures the final product has the correct shade. Each pile of clean, sorted material accumulates, ready to be transformed into new bottles or other glass products. Watching this stage is like witnessing a choreographed dance, where technology and human care come together to turn waste into something valuable and visually striking. With the glass now clean and separated, it moves on to the grinding process. Giant hammer mills crush the fragments into fine particles, almost like sparkling sand. Any piece still too large is automatically returned to the mill, ensuring a consistent and uniform flow of material. This step is essential for efficient melting, conserving energy, and preparing the glass for transformation into new bottles or recycled glass products. The crushed material, known as cullet, isn't just a physical preparation. It determines the energy efficiency of the melting process. Smaller particles melt faster, saving up to 40% of the energy compared to raw materials like sand or limestone. Grinding also makes it easier to mix in additional ingredients such as limestone, sodium carbonate, or metal oxides, allowing manufacturers to adjust color, strength, and other properties of the glass. Watching this colorful sand move along the conveyor belts is almost hypnotic, demonstrating how manufacturing is done with precision and care. As the cullet moves along, suction systems remove any remaining label fragments, leaving the material even purer. It's impressive to see how every step is designed to maximize efficiency and quality, combining industrial engineering, physics, and human oversight. Viewers can clearly see how things are made. A broken piece of glass is transformed almost magically into raw material ready to become new bottles, blending technology, sustainability, and visually striking processes into a single continuous flow. After grinding and preparation, the molten glass moves on to the molding stage, where precision is truly remarkable. Crucibles carry the material at temperatures exceeding 1,350 degrees, almost like liquid lava, while engineers monitor every detail to ensure consistency and quality. The mixture is carefully poured into molds designed with CAD software, controlling dimensions, thickness, and shape. Every step shows how glass is made with exactness, transforming crushed particles into shiny bottles ready for use. Inside the molds, jets of compressed air shape the liquid glass, forming the final bottle design with incredible speed. Every puff of air is timed down to the millisecond, ensuring uniformity and preventing imperfections. Watching this process is almost hypnotic. The glowing liquid stretches and adjusts, filling every contour of the mold. This is where industrial engineering meets the art of manufacturing, demonstrating how things are made with precision and stunning visual impact. Once molded, the bottles slowly move to the cooling area, where the temperature gradually decreases. This stage is critical to prevent cracks and deformation, allowing the glass to stabilize safely. Robots and human operators handle the gentle transport along conveyor belts, maintaining order and integrity for each piece. The result is breathtaking: newly formed, uniform, and shining bottles ready for final inspection, connecting viewers to the beauty and complexity of a meticulous production process. With the bottles molded and cooled, they move to a rigorous inspection stage. High-speed cameras and optical sensors check every detail. Tiny cracks, bubbles, or dimensional imperfections are detected instantly, ensuring only perfect products move forward. It's fascinating to see how technology identifies flaws invisible to the human eye, turning the process into a true visual spectacle of industrial precision. After inspection, the approved bottles are carefully organized by automated palletizing systems. Mechanical arms position each layer precisely, while protective sheets are placed between them to prevent damage during transport. Each pallet is wrapped and labeled according to the production batch, showing how things are made with extreme organization and care. The synchronization between machines and human supervisors ensures smooth operation and a visually engaging rhythm that keeps viewers' attention. This final care isn't just technical, it's strategic. Well-palletized products simplify logistics, reduce waste, and ensure every bottle reaches consumers intact. It's a perfect blend of industrial engineering and efficient production processes, showing viewers how things are made with precision and dedication. Watching this choreography of sensors, robotic arms, and operators creates a compelling visual narrative that keeps the audience engaged and curious about the next stage of production. After palletizing, the bottles move to the filling stage. Each unit is thoroughly cleaned with jets of hot water and steam, removing dust and bacteria. High-speed conveyors then carry the bottles to automated filling nozzles, dosing liquid with millimeter precision. It's incredible to watch how things are made, transforming empty bottles into ready-to-use products, connecting industrial engineering to everyday life. Once filled, caps are applied with precision machines that ensure a perfect seal, preventing leaks and maintaining product quality. Sensors verify every detail, from cap placement to exact liquid levels, showing viewers how industrial processes guarantee consistency and reliability. Any small defects are detected and removed, highlighting the importance of meticulous control on a modern production line. Finally, the bottles are packed into boxes, stacked onto pallets, and sent to cold storage or transport, ready to reach supermarkets and stores worldwide. Every stage reflects a process designed for efficiency, safety, and sustainability.